When things don't work, it's a chance for me to be like, things aren't always going to go perfect. But in Jesus, we just keep on persevering because we know it's going to be okay. All right, so we have 2 and then 3 and then 1 and then 4 and then 2. Trapezoidal sum. Okay, hold on, come back. So bases are delta x's or delta t's or delta whoever the independent is. Sometimes they're equal. Sometimes we make them equal. And sometimes we go with what we've got. So delta x's are going to be the bases. How do we, on the forever card, how do we talk about the heights? The y values, right? We could say the f of x values. And I'll say f of xn, and why am I saying that? If we have a subinterval from a to b, okay? We're finding the integral from a to b. In this case, in letter A, isn't it from 0 to 12? So our A would be 0, our B would be 12. We could call this, in an instance, or in some ways, we could call this x sub 0, the first. We could call this x sub n, the last. And then we could partition this, whether it's equal, I'm going to make it obviously not equal. We could partition this into different x values. You guys tracking? So as I was to jump here, that would be base 1. As I was to jump here, that would be base 2. As I was to jump here, that would be base 3, 4, and base 5. I could find subtracting the differences, and those would tell me the bases that I could use in my rectangles. But how do I find the heights? Let's talk about left versus right versus midpoint. Let's talk about left versus right versus midpoint. When dealing with our A1s, A2s, A3s, etc., etc., etc. I'm going to go ahead and pause the video just because this is up on the smartboard, so it's kind of hard for anybody who's watching to go ahead and see. Nope, that didn't work. That just went to a different thing. So let's start with, there was calculator, non-calculator, right? Non-calculator came first. So non-calculator, number 1. Non-calculator number 1. And remember, guys, could you put the information on the board in your when you see you think? Yes. Could you add it to your forever card? Yes. Could you take a picture and just reference it enough that hopefully you remember it? Also, yes. Okay, here we go. Give me something, if we have something. Any questions that you guys have? Oh, on the calculator part. Number 7 on the non-calculator? Okay, we'll get back to that one. Anything else on the non-calculator multiple choice besides 7? Going once? Okay, let's go to 7. That's the one that I've heard a few times. So number 7. Estimate. Estimate. If we were to solve, we would take the antiderivative, plug in b, plug in a, subtract FTC. But it says estimate, and then it says a right Riemann sum with 2 equal subdivisions. We're making it. Here's what I do. Do you guys see how I drew a number line up there? Number line from pi over 2a to pi b. And it says 2 equal subdivisions, meaning 2 jumps. Well, if it's 2 jumps, then I need to go halfway in between, right? So halfway in between pi over 2 and 1/2 and 1, isn't that 3/4? Now, could you have found that yourself by saying b minus a all over n? Here's a good application. Because then that would end up being, if I multiply top and bottom by 2, thank you. If I multiply top and bottom by 2, I'd end up with, this is my cheater trick, remember, to get rid of complex fractions. You could also, gotten common denominators multiplied by 1/2, the reciprocal of 2 over 1. You get 2 pi minus pi all over 4. No, not minus. B minus a all over, oh sorry, you're going by pi over 4s. You're going by pi over 4s. So if you did do b minus a all over n, that's the length of each of the subintervals. So what's the distance between pi over 2 and 3 pi over 4? 1/4 pi. What's the distance between 3 pi over 4 and pi? 1/4 pi. The distance is pi over 4. Okay, now that I have that, they said right Riemann sums. So kiddos, check what we just did up there. Right Riemann sums, I can say that my area is going to equal, which would be the same thing as saying my integral is going to be approximately, okay, what's the base of the first one? 3 pi over 4 minus pi over 2 is pi over 4, which we also found by that. pi over 4. And then I'm going to do my f of, so why am I writing sine? It's my f. Good. Good. That's my not my antiderivative. That's my integrand.
Wait, are you saying pi over 4 because how much you're going between?
Because that's the distance. Yeah. That's the distance. And then who am I using if it's a right Riemann sum? Good. You look at these two and say the one on the right, 3 pi over 4. And then you're adding the base of, since we did it, it's equal, but otherwise we just subtract the 2. Also pi over 4. But now it's going to be sine of, good, the guy on the right. Now, struggle. Some of you still need to highlight unit circle, right? Okay. But now that you have this, now you just need to figure out what's going on. First of all, I'm pretty sure we could probably cross out a, because it seems like there is a pi over 4 that we can pull out. Sine of 3 pi over 4. It's going to be negative root 2 over 2. No, positive, because sine goes up. Good. All students take calculus. Plus sine of pi. Well, isn't the y value 0? Unit circle. Okay. Any other questions on the non-calculator multiple choice? Non-calculator FRQ. Okay. Letter C is a great question. We know differentiable, we know straight line. Okay, let me scroll down here. What's the difference between approximate and true? Actual, right? Like the exact, like the perfect, like you solve it, right? The approximate is the Riemann sum. So were we okay on the approximate on the Riemann sum? Okay. So let's say we're good on the approximate on the Riemann sum. Then it suddenly starts asking about true. If it asks about true or the actual, you could say true or actual, it means actually solve it. Kiddos, just yesterday, didn't we talk about the fundamental theorem of calculus? And didn't the fundamental theorem of calculus say, if you could just find the antiderivative, capital F of B minus capital F of A, but wait, to find the antiderivative, don't I have to think about, ooh, this guy is the derivative of somebody? Couldn't I rewrite this to be 0 to 12 of V prime? Who's the antiderivative of V prime? V. It's as simple as V of 12 minus V of 0. The antiderivative of A, go back a jump. Remember, position is the OG. Velocity is the derivative. Acceleration is the double derivative of position or the single derivative of velocity. Go back a jump from acceleration, you get to velocity, V of B minus V of A. And the cool thing is, check out the table, we know V of 12. We know V of 0. If you want to be really obstinate, you could totally just leave it like that and be like, I'm not going to simplify, but pause. You have to put the units. So who are these guys? V's. What units are V's? Meters per second. Dun, 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 dun. Such an easy problem and yet such a hard one to see. On your FRQs from the mock AP on Saturday, there was something where you had F double prime of X dx from I don't even know what, an A to a B, and it asked you to solve it using a table of prime values. Of F double prime? It was as simple as going to the table, then plugging in. It's rough for Saturday, but it's good for now if you're like, I get it. Pause. What is this falling under as far as how could you study this? Fundamental theorem of calculus. Antiderivative of B minus antiderivative of A is how you always actually solve any integral. Does that make sense? Graphing calculator stuff. I'm going to go ahead and as you guys are getting those questions, let me actually open up my graphing calculator, because a few of you actually need help on how to use your calculator to do the basics. And that's okay. It's not a bad thing. What do we got? 3? Okay. So 3. Ooh, this one's good. Kiddos, they're saying L sub 3, R sub 3, T sub 3, and M sub 3. I think that's basically indicating n equals 3. That's what these 3 are, n equals 3, n equals 3, n equals 3. But here's what I see. If you see a function that is strictly increasing and concave down, basically not changing from increasing to decreasing, not changing from concave down to concave up, but it's strictly having one first derivative behavior, increasing, decreasing, and strictly one second derivative sign, concave down. What it's going to do, whether n is 3 or n is 10 or n is 100 or n is 1, is the same thing. Let me show you what I mean. If I was to choose left, and you could do several of them if you want. Go from the left, go from the left, go from the left. Like, all left are going to be what kind of approximations? Go from the left, under. So I know right now that L is super low. L is going to be under. Another way of looking at it, if you were to do n equals 1 subinterval, your L height would just be 0. So the lowest this area can be is 0. It's higher than that, obviously, but the lowest it can be is 0. So L3, in a sense, is going to be the lowest bound. If I'm going from lowest to highest, sure. How about R? It's going to be over, right? And you can think about it. What if you had one big one? If you had one big one, isn't that really over? So what is, something else with the Saturday FRQ. What is the highest this region can be? It would be the highest height as a rectangle. That's the highest it could possibly be. It's going to somewhere be between 0 and the highest, which would be the height at 6 times 3 is what, 18? That's the highest it could be. So coming from the right is the highest. Now, if I was to do, what's the next one that comes in? Trapezoids. Trapezoids. Remember you would connect the points? Connect, connect, connect. Can you guys tell if that's under or over? Under, because the curvature is going to go a little bit above. Now my lines are kind of rough because my smartboard marker is thick. But the trapezoids are going to be under, right? So if the trapezoids are under approximations, it seems to be, I'm going to put a little like T3 right here. It seems to be towards the underside, but we're not quite sure about M3. Right now I know T3 is in between, but how about M3? M3 would say take the little midpoints. 0.5, 1.5, and 2.5, and go hit. And go hit. And go hit. Huh. Isn't he a little bit like over and under? Over and under, over and under, over and under. Well, that's kind of hard to see. What if you were to do one big trapezoid? Oh, no, we already figured out the trapezoid. One big midpoint. What's the midpoint of 0 and 3? Isn't that 1.5? Okay, what if we were to do one big? What does it ultimately end up being if you look at this midpoint? A lot more over than under. So what kind of approximation is he? Because the midpoint is the midpoint of the x's. It's not the midpoint of the y's. It's not perfectly cutting the over and under in half. They're not going to necessarily be equal. Check it. It's more over, right? So if it's more over, so if we take those two and if we move those two up, that's not working very well. But if we move these two up, throw in those inequalities, and then only one of them is going to make sense as far as which one, is not true. So which one is not true? There is no absolute way that the midpoint is less than the left. The left is the very lowest. So therefore D. There's no way. The left is the far, 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 far lowest. And maybe you didn't need to analyze the whole thing, but that is one way of thinking about it. Kiddos. Spent a little too much time on things, but that's okay. Go ahead and pass up your LTF number 6s. They will be done by, your 5s. I have them. Pass up your 6s. 7s, the odds are due tomorrow. You might have a couple more questions on 6s. No big deal. We'll get them back to you tomorrow. But let me take your 6s, and let me give you 5s to pass back. Let me give you 6s, and let me give you 5s. Oh, you have some of them too. Any more 6s? Okay. Let me take the 6s. And let me give you 5s. Oh, Caitlin, here you go. I don't know. That's all of your guys's. Let me pause the video.